Durant education, we make math and science easy by making subjects relatable and learning fun. Science in one demo video. The force with which the Earth attracts a body. The distance and displacement. Displacement is the distance and direction of an object's change in position from the starting point to the finishing point. It is free-falling bodies. When an object is influenced only by the force of gravity, it is said to be in free fall. The gravitational attraction of the Earth causes all falling bodies to have an acceleration of 9.8 meters per second squared. Scalars. A scalar quantity only has magnitude, that means size. Examples of scalar quantities: we have mass, volume, area, distance, heat, temperature, and speed. Distance, displacement, speed, velocity, time. Acceleration is equal to final velocity minus the initial velocity over t. Calculate acceleration if a motor car is moving from rest to 90 kilometers in 20 seconds. Free falling bodies. Gravitational force G. When an object is influenced only by the force of gravity, it is said to be in free fall. All free-falling bodies have the same acceleration. It is 9.8 meters per second squared. Velocity time graph. The velocity time graph for a body with uniform acceleration, that means free-falling body, is a straight line. Calculate the weight of a car with a mass of 1,200 kgs. The effects of a force. A force can make a stationary body to move. Newton's second law. A net force causes an object to accelerate in the direction of the net force. Definition of a force. A force can either be a push or a pull. Definition of a resultant, equilibrium, and equilibrate. A resultant is that single force that can replace two or more forces and produce the same effect. Parallelogram of forces. Example, determine the magnitude, that's the size and direction of the resultant of the following coplanar forces. Coplanar forces. We got two forces, pulling forces, 150 Newton. That's my first one. 150 Newton, according to my scale. 40. It's on the dot there. 40. There's different ways to do it. That's 10, 20, 30, 40. So I can mark there. Now I've got the mark of the 100 millimeters. So I connect Dalton. Sorry. And now I have to find the magnitude, the size of the resultant. Measure that. That is 240
40 millimeters. So in other words, R is equal to 240 millimeters. Remember, in the opposite direction of the resultant, the equivalent. Okay, it's the same magnitude as the resultant, but in the opposite direction. Okay, the equilibrant.
Moments of forces at work. We have a load in kg and the supporting beams carrying a load. Torque. Levers with one force acting. A lever is a rigid bar, example a spanner. When it is used to produce a turning moment, is usually referred to as torque.
Free energy. Objectives: define and discuss the following forms of energy: potential energy, kinetic energy, heat energy, electrical energy, chemical energy. Nuclear energy and solar energy is not discussed in this syllabus. Potential energy. Gravitational potential energy. It is the stored energy of an object due to its position.
The resting body has got potential energy. The object has got no kinetic energy when at rest. Potential energy is m times g times h. Calculations are not necessary for N1. The amount of gravitational energy depends on three things: the mass of the object, the height above the ground, and the acceleration.
Or natural gas contains carbon and hydrogen atoms, and energy is released when the petrol or gas burns.
Kinetic energy. We show you some more forms of kinetic energy. We have a rocket being propelled and a car driving. Chemical energy to heat energy and then transfer to mechanical energy. Electrical energy to heat energy Science in 1, Module 5, Particle Structure of Matter. Three phases or states of matter. We have solid, liquids, and gases. Gases at work. Hydrogen and oxygen combines in the combustion chamber, which propels the rocket. Motion of particles within gases. It is very fast because the molecules are even further apart. Particles move slowly in solids unless there is a change in temperature. In this case, the steel is heating up. Science in 1, Module 6.1, Electricity. Electricity, a source of life. Electricity is the flow of electrons. Note the current flow in a conductor. In electrical pressure must be present to cause electrical current flow. Electrical charges flow from high voltage areas to the low voltage areas. Workbook. Circuit. You read this yourself. We've given you a pictorial diagram.
A current of 6 amp flows through a resistor when the potential difference is 220 volt. Equal to V over I equal to 36,6 ohm.
Parallel. Adding resistors in parallel decreases the overall resistance. The potential difference or voltage will be the same for each resistor. The formula to calculate the resistance in parallel is 1 over total resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Example. 3 resistors with value of 6 ohm, 4 ohm and 3 ohm respectively are connected in series. Calculate the total resistance of the circuit. Pause the video.